She reaches for your hand, she talks baby nonsense to you, smiles and learns how to crawl. Maybe she says a first word or two. She sits up, plays with toys, even turns pages of the book. Then suddenly the nightmare begins. Around the age of 6 to 18 months, your daughter stops turning pages, speaking and walking. She develops anxiety attacks as a baby and plays with toys less and less until one day you realize she can't use her hands at all to do anything except bring them. What happened to your normal little baby girl? Your once normal daughter becomes severely handicapped and all forms of communication disappear. All forms of communication disappear. After months or maybe years, you finally get a diagnosis from one of the many specialists you've seen. Your daughter has Rett syndrome. You learn that within a few short years, your daughter will develop scoliosis, breath holding, heart rhythm problems, a compromised immune system, and epilepsy. On top of the digestive difficulties, loss of speech and motor control, and anxiety attacks that she already suffers. Rett syndrome is caused by a mutation in our MECP2 gene, which is found on the X chromosome. So because a girl has another normal copy of the gene in her other X chromosome, some function related to the MECP2 gene is retained because any cell contains either a mutated copy of the gene or a normal copy of the gene. Boys with the condition are not so lucky because they have an X chromosome and a Y chromosome. Every single gene for MECP2 is mutated. So normally boys don't make it past the fetus stage. So scientists don't really know what it is that MECP2 gene does, but they do know one thing about it. It's a master gene. So normally when you and I think about genes, we think about blue eyes, brown hair, which are very simple genes. So they act like a switch. They're either in the on position or in the off position. So MECP2 as a master gene has a much bigger role. So imagine it this way. So say we're in the 1940s and you want to place a phone call to your sister across the country in New York City. So you pick up on the phone and across town a bulb lights up on a phone operator switchboard. And she picks up the phone and she says, "Where would you like your call connected?" And you tell her, so she connects you. It goes to another town, they ask you the same question, and you get connected again, until eventually you get across the country and you're speaking to your sister in New York City. MECP2 is a switchboard operator. The people placing calls into the operator are various genes. This is why Rett syndrome is so devastating. So a mutation in the eye color gene is pretty much going to affect just the color of your eyes. A mutation in a master gene interrupts communication across the board between all genes. A 2007 University of Edinburgh study created a strain of mice where the MECP2 gene could be switched off during the developmental stage of mice. The mice manifested many Rett syndrome symptoms. So since the scientists, they weren't sure what the long-term cause of a lack of MECP2 gene causes in the brain. So they were curious to see what would happen when they turned the gene on. When they turned the gene on, they were amazed. The symptoms reversed, even in severely disabled adult mice. The study proved that Rett syndrome is not caused by cellular death in the brain or even degeneration. The switchboard equipment, it's not broken and it doesn't need to be repaired. They just need to hire a switchboard operator. In August of 2013, the Journal of Neuroscience article announced results of an amazing study. So a true Trojan virus, not to be confused with computer viruses, but a true virus was created where they took the most important pieces of the MECP2 gene and they put it on the virus along with the promoter code that would turn the gene on. They couldn't put the entire gene on the virus because the virus couldn't hold it all. They took these same mice that had the MECP2 turned off and they injected them with the virus. Within 4 to 5 weeks, the mice were almost normal. With only 15 to 30% of the mice neurons receiving the corrected DNA, near normal function was restored in all adult mice. The researcher was shocked at how little of the corrected DNA was needed in order to create this near normal function. So a mouse with Rett syndrome will not groom itself, it will not walk, it doesn't eat very much, it's very, very small and will not explore its environment. These mice, within a short period of time, grew, became healthy, and would explore their environment and create nests. So you think, well, now we have a way to cure Rett syndrome. Well, Rett syndrome has a brother syndrome called MECP2 duplication. This syndrome is caused by a mutation allowing for 2 copies of the MECP2 gene, healthy copies, to work at once, causing many of the same symptoms of Rett syndrome, though most of the boys with the disease don't make it to their 25th birthday. So Rett syndrome treatment walks a fine line. We must restore function of the MECP2 gene to the cells with mutated genes, but not to the cells with healthy genes. Rett syndrome affects 1 in 10,000 girls. As a rare disease, it receives very little funding because no one even knows what it is. Neurological disorders. Rett syndrome will be the first neurological disorder that we will reverse in humans. This is not just a hope thing. This is what researchers say. This is the first neurological disorder that we will reverse. Neurological disorders include Alzheimer's, Parkinson's, and autism. It is thought that treatments for Rett syndrome will spill over to treatments in other neurological disorders. In fact, Parkinson's disease shares some of the same gene mutations on MECP2 that Rett syndrome does. And types of autism have similar onset pattern as Rett syndrome. Rett syndrome needs you. It needs your voice, it needs your support, and it needs you to know what it